This is answering the question for Jenny. Jenny, yes, that we need to convert from the C++ class back to JSON. That's the homework assignment part one. That's why I talk about the function called dumpj. The member function dumpj is exactly designed to accomplish this. That once you put this JSON format objects into C++ objects, and then basically we just call this dumpj from the highest level, it will actually automatically print or convert the content of the object back to a JSON format, okay? Um, oh, the question is, how do we convert the JSON string, a JSON string into a JSON value objects? Let me try to understand your question. How do I parse? Oh, okay, okay. So that's the code to convert a string. I assume you mean the string into a JSON value object. That is I'm going to share my screen. Okay. Okay, I assume you can see my screen. So this is the code I was sending you as a simple code for HW1 parse. So I have a program called HW5 parse.cpp. So this program is essentially convert the JSON string into JSON value. So what I did is that this code essentially is try to read, right? Of course, this part is try to open the file because we need to take that JSON file into our program. And this part of the program I'm showing you is really just reading the file. I'm actually trying to read the whole file using this fread to read the whole thing. So the result is what we call the JF pointer. So we have a JF is the file pointer to the JSON. And JF pointer, as you can see what we have, we define JF pointer. Where do I define JF pointer? Okay, JF pointer is a pointer to a string. So essentially now JFPTR is pointing to a JSON string. Okay, so that is the file that I just allocate the memory. I want to see how big the file size is. If you look at this line, I'm basically allocate memory space that's actually similar to the size. In fact, I just realized I might have to +1 instead of just L size, but that's probably okay. And then I do a fread to read from the file to that string JFPTR. Okay, so JFPTR is a string. So this part of the code is nothing to do with parsing into JSON values. Just basically take the file which contain the JSON string into this program and use a pointer JFPTR to pointing at that. Now you are going to see the JSON value part. It's just this piece of code. Okay, it's this piece of code. In fact, it's just this piece of code. Even shorter is actually this piece of code. Okay. Okay, so how do I do that? Number one, you declare a JSON value, which is the message. Okay, you declare that. This two line is just try to build. This is from the JSON library. You have a way to define something we call reader, which we will be able to parse the string. So if you define the reader this way, you define the builder and the reader, and then what you have, of course, you define the arrow because the parsing might have arrow, and then the real trick is just this line here. So essentially, I call this reader parse function. Okay, reader is a JSON care reader class. So it's a pointer to that. So reader pointing to the parse, and then with this 4 parameter. The first parameter is the J of PTR, which is a pointer to that JSON string I read from the file. That's the first one. The second one is essentially is the JFPTR plus L size, which means the pointer to the end of the string. So I have the beginning, which is the first argument, and the end of the argument, which is the second argument. So I have a 2 pointer here pointing to the beginning and pointing to the end. And then this is the output, means that this is the MYV message. Why is MYV message? Is the JSON value I created here. And then I put passing, this is called by reference, so I use the M sign, which shows that it's the address of that result I was going to put it in. And of course, the arrows as well. So essentially what you have is if this is a successful, then basically you will get your JSON string into your JSON value. And then once you have your JSON value, then you can basically see my last line. I just printed. I just say MYV message dot to style string. You see that in my program, I use to style string a lot. It actually helps you to print the JSON very nicely. Okay. Does that answer your question, Jenny? Let me see the. I cannot see chat anymore when I share the screen. Is that right? Oh, no, that's the question asked by, I think, asked by John. Wei Pen, I forgot about what we discussed yesterday about different classes. I did have recorded. I already upload the recording. Okay, I can probably do this. Let me see if this makes sense. So this is all the, let me do this. This is all the classes I have. I have a core.h, of course. I have a person.h, but I also have a post.h, comment.h, reaction.h, and of course the rest are even simpler, like a tag.h, message, my time. Oh, I mentioned in my presentation in class, I will give you the my time.h and my time.cpp, which help you to process the time format that in the JSON. That part will save you some effort because if you haven't done this time processing before, this might be a trouble. So I'm going to send that to you and then from the announcement. Okay. So these are the class I have for homework assignment number 5. But I do want to say, because Wei Pen asked, this is the post.h. I just show you the code, post.h. And post.h has include all other classes because it's the highest level. It has the information that contain one big post JSON. And you can take a look at, this is my definition of post. I mentioned that for simplicity, I just put everything in the public for me to get moving pretty quickly, okay? So I have, this two is ID, and let me show you again what I have the other day. Let me use my slide. Maybe it's easier to do the slides. So this is essentially trying to representing this one. Okay, this one is the whole JSON for base input JSON. And the first two, let me actually try to match with this. The first one is called profile ID and post ID. The profile ID and post ID correspond to, let me actually show you that the ID has two parts. This one is the profile ID, is equivalent to the VSID. And this part is the post ID. So it's basically have a two portion of the ID. This is a convention for the Facebook when they declare all the posts and message. The reason is the first one is the profile ID, means who, from which page or which group or which person's profile that you actually post this particular post. Therefore, the ID consists of two parts. One is the profile, which is ID of a person or ID of a page. And then within that page, what is the post has a unique ID. And this two add together is what we call the ID of this identifier of this post. So that's why I have, sorry, let's talk about this. That's why I have two. One is the profile ID, one is the post ID. Okay, and then we have a person, which is the author. The person is actually get it from the next one, which is a from. This part is a front. Let me use a different color. Let's use green. Okay, this part is a from, has a name, has a VSID. Represent from, that is author. And then we have what we call receiver, which is two, which means that is an array of receiving end of this post, which means that now I have this part two, which is an array, and which count as a one because right now I only have a one for this one. So this one I'm going to use another color yet. So this part is two. And then you have your message. You have your message. Message is just the string over here. This part is the message. Let me use what color? Okay, I use red again. Sorry. Okay, this part is message. Then we have a link. Then we have a link. Let me pick another color. Let me use the blue one. This is the link. It's also an array. And if you go back, now I have a link here. Okay, so you can see that I'm actually the way I designed this post is following the order of information I got from that JSON. And for each of them, I have this, okay? So just show you another class, which is also quite relatively more complicated. Let's look at comment.h. Okay, here is you have a set of comment, right? So let's look at comment.h. Comment.h is like this. It's slightly complicated, but it's not so complicated. So a comment has an ID. ID has a profile ID, post ID, and comment ID. So now let's look at the comment. Let me pick a comment. Okay, here's a comments, right? Here's a comments. It's an array, and look at each of the element of the comment. Is like this part is a one comment. One comment until, wait a minute. Yeah, until here is one. Let me see. It must have another ID. Oh, no. No, this is one comment, sorry. From here all the way to here is a comment. It's a one single comment over here. Yeah. Over here, I'm going to use the red to represent. I'm going to make it bigger, okay? So you can see this part. Make it bigger. How do I make it bigger? This way? Okay, I'm happy. So this part, let me make my window a little bit bigger this way as well. Okay. So this part is a comment. Let me actually parse it in a different window. Let me get rid of this first. Sorry about that. So this is the data I pick up. I actually need to remove the first few characters. Okay, so this section is actually the comment part, the first comment. I totally have a two comment in the base JSON, but this is only the first comment. And the comment looks fairly complicated, but we can actually break it, okay? So let me actually break the comment this way. The first one is the ID. The ID is here. The second part is a from. The third part is the message. And then we have a creation time. Can you go back? No, I cannot. I have to do this. And then you have a reaction. And within the reaction, it's another array. Okay, so this part is all reaction. I'm going to, let me do this part. This part is all, everything here is reaction. Like, let me use a reaction using a different color so you don't get confused. Okay, so except the last part is a reaction, the rest part is a comment. You have ID, you have a from, you have a message. Okay, that's, and then you have a timestamp. That's pretty much everything you have as a oh, I should probably put this one here as well. This is not part of the reaction. Okay, so this is, you can think about this is a sub JSON out of your original JSON, which represent the comment, okay, with ID. But I want to tell you that here is ID. ID has three parts. The first part of the ID is a VS ID. It's just like a post ID. Sorry, it's a profile ID. So this one is a profile ID. The second part is the post ID because this belongs to the post. The second part is the post ID. And then the third is the comment ID because you can have lots of comment. As I mentioned to you that some of the posts, just one post has about 500,000 comments, and you need to identify them uniquely. So this is the ID part with these three things together. That's why in my design of the comment, I have three ID. I have a profile ID, post ID, and comment ID. That's my design, by the way. You decide what's the best to handle this. I don't restrict you, but I actually have this three, so I can do something. And then I have this person as author, which is, you can see it's very similar to the post, which shows the author, which is the front. And for comment, I don't have a two. For comment, I don't have a two, so that's why I don't have a two. But I do have a message, just like in the post, and I have a created time. Okay, the time, I have that. And then I have a vector of reaction. For this particular one, you don't need the vector of text, but on the other posts that I do have the text being there. So that's why I have a tag here. And then you have this one is constructor, and this one is just the dump J. I have a program to dump J on this one. Okay. So this is how you look at the information compared from the JSON to the C++. So just let you know, the way I do it is that I design a reaction class. So I parse this, but also I reuse the reaction, because you can see that here, my reaction, I'm just using the reaction array again, just like a post. Post, I also have a line like this, and I have a line like this here as well. Okay. All right, so having said that, let me check my comment. Yeah, pretty much I have everything. Jenny, you're asking about 10.h file. I do have everything except my message.h is so simple, so I didn't have a message.cpp. I only have a message.h. I don't think I have. Oh, hold on 1 second. Let me actually share the screen again. So message, yeah, I only have a message.h because message is really simple. So I didn't even have it. It's really just message is just the content, the constructor, and I have a set content and get content. That's it. So I just implementing .h. I didn't even bother to have a message.cpp. It's probably a bad habit. Okay. Let me check. Okay, I'm going to post it, Andrew. I'm going to post my time on the Canvas and Facebook, so you can actually access to those codes. I'll do that this afternoon. I do want to say, Jenny, your question about if not defined or and if, okay, this is a convention from the C world. Okay, it's also very useful for C++. So let me actually tell you why this is needed. Okay, so when I say if not defined underscore message h, this means that let me actually copy and paste this code to my PowerPoint so I can explain to you what's happening here. Let me get rid of this. Okay, let me, wow, it's pretty big. I have to, Okay, I think I can explain now with this, with everything in the same window. So I just copy and paste. This is my message. Okay, so this if not defined here is a guard for this content. And this if is actually closer with this one. So these two are actually matching with each other. These two are matching with each other, which means that
You didn't share your screen.
oh, I didn't share my screen. I'm sorry. Thank you. Thank you, John. Can you see my screen now? Okay, yeah. Good. Thank you. So this statement, if not defined message underscore h, is actually matching with this end if, the first end if encounter. Okay, in this picture. So essentially, everything in the middle is protected by this if not defined pair. Okay. So what does that mean? Means that the compiler will check when this is, in fact, it's not even deal with the compiler, it's specifically deal with a step in the compiler called preprocessor. Okay, this is essentially being done, we call it preprocessor. This is also, by the way, preprocessor is also done by what do you call that? The G++, but if you do G++ minus E, capital E, that means it will stop after the preprocessor stage. So just let you know. Okay, so in the preprocessor step, up to this point, if it actually see that the underscore message underscore h has been defined, then it will not go into this, this body of code. So essentially, this is trying to guard whether that condition actually met, that you won't do that. Okay, you will see, I later will give you an example about using if def and if not def. So there's two flag here. One is called if def, one is called if not def. Okay, not if defined or if not defined, but you will see the difference later. But I want to show you if not defined means that unless that this has not been defined, I won't actually get into this piece of code. So why I'm doing this, because you see that I'm usually adding another line of code immediately after you go in. I define. I said define this string. So I first said if not defined. When I go in, I define. This means that I want to make sure that this piece of code I'm protecting, I'm guarding, will only be included once. So that's what it's trying to do. It's trying to make sure that this will only be included once. So once is if not defined come in, I already define. So if there is some other code who also include message .h, it won't be included again, because if you don't have this, you're going to have a duplicate declaration and definition, because you define the class message twice. That's why for every single .h file, we actually have this if not defined, define, and then at the end say and if, to basically make sure that you don't have the you won't include the same declaration twice. That's the only reason for you to do that. Okay. Any question? Okay. So I want to show you another piece of code, which I think I have it here somewhere. I will use this as an example. I thought I'd talk about this one. Oh, okay, here is an example. Here example, you see I'm using if defined, not if not defined. I said, if you define this, then I'm going to include this piece of code, and until I hit my next end if. So these two are the pair, actually. if define, and if. Those two are paired together to guard this piece of code. So it means this piece of code will only be included unless that this particular symbol is being defined. Okay, so typically how do I control that? I typically control that in the make file. So let me actually show you how I would have done in my make file. So typically in the make file, you see I have this C flag, right? I mean, my C flag looks like this, but I could actually write 2-line. I typically will do this. I have a 2-line, but in my C flag, I will actually say minus D, ECF 36B debug. If I actually do this, let me check my code, make sure I have it correctly. ECF 36B debug, yeah, that's correct. So I typically include this in my C flag. So which means that when I call the G++ compiler is going to put, remember the C flag is actually going to put it here in the compiling stage. So it will actually, minus capital D means I actually define the symbol. So when you do that, then it will trigger this flag because it's defined. Then this statement, it will be included in the compiler, and then it will print out the debugging. Because usually I will have a 2-line, because when I'm doing debugging, then I want to use this line. But say today I'm done with debugging, I want to really just see the result, I can just uncomment this and comment this back. And then I can have another version of debugger, okay? Okay. Let me stop it. Yes, Jenny, every .h file you need that. Anywhere you do a declaration, you pretty much need to have that. Yeah, it's if you don't do that, not always happen, but you will get a lot of error message sometimes because duplicate declaration. I think so. I checked yesterday, Aldo, the server. It was up. Maybe I should do that again to check. Let me check very quickly. Oh, it was down. Aldo, I'm sorry that it was down. I checked yesterday, but somehow it's down again. I just bring it up. Okay.
I have a question.
Manuel, just hold on 1 second. I'm actually trying to answer a question from Andrew. After I answer this question from Andrew, I'll get back to you, Manuel.
Okay.
Andrew is asking, where do we implement the function to reconstruct a JSON from the object? Okay, so Andrew, this is my implementation. I use a dumpj to do that. I use the dumpj to do that. So dumpj is a part of the program I mentioned in my video lecture number 10. So take a look at that if you haven't. But if you have any question, let me know. Okay, I can explain more detail. But essentially, what we're talking about is that dumpj is a small function I wrote to convert the content of the object back to the JSON format. So essentially, it's converting the C+ object back to JSON value. JSON value. I'm not constructing the JSON string, but I construct to the JSON value, because JSON value is a JSON object representation in C++ of the JSON. And then with the JSON value, then I can just call to style string. I can generate the JSON string. So just let you know that is a function called dumpj. And the way I designed dumpj is that instead of writing a one big function, try to dump everything. Dumpj is the idea of a recursively call the dumpj function in other class. So pretty much, let me do a graph very quickly to show you how many object I have the dumpj program. So I'm going to say, this is my .h file. I have this many .h. I will just grab dumpj star.h. And you can see I have 1, 2, 3, 4, 5, 6, 7. I have a 7 dumpj program function as a member function. Action, comment, link, person, post, reaction, and the tag. And when I need to construct the object, I just call post object. I just call post dumpj, and then it will recursively, because post has a comment, has reaction. It will recursively call the dumpj from the comment object and things like that. And we just put them together. We have the whole dumpj. Okay. So Andrew, do you have some question before I move on to the next question?
I'm good, thank you. I'll take a look at the video, and if I have more questions.
Sure. Okay. Sure.
Thank you.
Let me know. Okay. Okay. Do we put include before the if not defined? Usually, okay, there is no particular rule saying that you cannot put which one in the front, which one in the back, but it depending on whether that include statement is being protected inside this statement. So I would say, because usually the include statement, if you have any system file you include, they all should have that protection as well. So if any statement that's actually include statement, you put it inside or outside, it won't hurt you, because that includes supposed to have that as well. But it's really protecting is the class definition itself. Okay, I think that is John's question. Yeah, so what I'm saying is, since it doesn't matter, so I always put that if not defined at the beginning, and then the end if at the end. That's one safe way to do that. Okay. Jenny, yes, you can do that as well. You can do that. It just potentially that file becomes so big. Okay. Although the server is up. Okay, Manuel, sorry for the wait. What's your question?
I wanted to ask if we ever got, I think it's example or sample program 1206 fixed, or we got it like solved with the randomization.
Yeah, I haven't fixed everything, but I know that the number 8 has been fixed, and the rest of the program, what I plan to, I just haven't get to that point. We're going to remove those link from the
Okay.
sample program, so it won't actually bother us. We will remove that. Yeah, I noticed there are like 1 or 2 program. I already know that some of the student already reported. We haven't got a chance to do that. But yeah, that's something which is urgent to do list. We have to do that. Yeah.
Okay, thank you.
You're welcome. Jenny, you're asking for homework file or for small program? Homework file, you have to have a makefile. You have to have a makefile. In fact, it's required. So TA and me were discussing the grading policy for homework 5. So one of the very important requirement for homework 5 is that your program will compile. Your program will compile when we just type a make. We type a make with a make file, that it will compile, which means that you have to have a correct make file. Yeah, and that's very important. And I think we will soon announce the like a grading policy for 5 is that at what stage, how many percent, how many partial credit you're going to get. So one of the requirement, make sure that you have a correct make file. Your program won't crash. Your program don't generate an exception, things like that. Okay. Okay. Any other question?
And then for the make file for homework number 5, should we just look, I guess, look back at the previous homeworks for, I guess, setting it up? Because I know you provided some links on like the make file and stuff, but
Yeah.
there's also some like little like super technical things that go everywhere. But
Yeah.
yes, we just
Yeah. Try to follow the example. Follow the example. Very similar. And also, I posted on the Facebook a tutorial for Makefile, a simple Makefile tutorial, and maybe that will help as well.
Okay.
Okay, let me, if we're getting a bit quiet, I'm going to pause the recording, okay? And then we can, wait a minute, where's my recording? Okay.